Each fire pump requires an automatic transfer switch, or ATS, and a fire controller. The ATS is necessary to ensure each fire pump has a dedicated and reliable power source in the event of a utility outage or standby generator failure. It will automatically transfer the fire pump from the utility to the standby generator in case of a utility failure. The fire controller is a crucial component that monitors and controls the fire pump's operation. It receives signals from smoke detectors or fire alarm systems and initiates the fire pump startup sequence. It also monitors operating parameters and provides protection against overheating, low water pressure, and other potential failures. Having an ATS and fire controller for each fire pump enhances system redundancy and reliability. If one fire pump or its associated controller fails, the other fire pump can still be activated and controlled independently. NFPA 20.1 standard for the installation of stationary pumps for fire protection, and NFPA 110.1 standard for emergency and standby power systems typically require each fire pump to have a dedicated ATS, fire controller, and power source. Overall, each fire pump should have its own ATS and fire controller to ensure that there is a reliable and independent power source and control mechanism in the event of an emergency. Let's delve deeper into the specifics of these requirements and their importance. The automatic transfer switch, or ATS, serves as a critical component in ensuring uninterrupted power supply to the fire pump. Its primary function is to automatically switch the power source from the normal utility supply to the emergency standby generator in the event of a utility power failure. This automatic transfer is crucial because fire pumps must operate reliably during emergencies, and a power outage cannot be allowed to compromise their functionality. Consider a scenario where the utility power fails due to a natural disaster, grid instability, or equipment malfunction. Without an ATS, the fire pump would cease to operate, leaving the building vulnerable to fire damage. The ATS detects the power failure and immediately initiates a transfer to the standby generator, which should start automatically upon sensing the utility power loss. This entire process typically occurs within seconds, ensuring minimal downtime for the fire pump. The ATS continuously monitors the utility power and, once it is restored and stable, automatically transfers the fire pump back to the utility supply. This automatic switching capability is essential for maintaining continuous fire protection without manual intervention. The fire controller, on the other hand, is the brain of the fire pump system. It monitors and controls the pump's operation, ensuring that it functions correctly and efficiently. The fire controller receives signals from various sensors and devices such as smoke detectors, fire alarm systems, and pressure sensors. When a fire is detected, the fire alarm system sends a signal to the fire controller, which then initiates the fire pump startup sequence. The fire controller also monitors several critical operating parameters, including pump pressure, flow rate, motor temperature, and water levels. If any of these parameters deviate from the normal operating range, the fire controller takes appropriate action, such as adjusting the pump speed, sending an alarm, or shutting down the pump to prevent damage. One of the most important functions of the fire controller is to protect the fire pump from potential failures. For example, if the pump motor overheats, the fire controller will shut down the pump to prevent motor damage. Similarly, if the water pressure in the fire suppression system drops below a certain level, the fire controller will activate an alarm to alert personnel to a potential water supply problem. The fire controller also provides diagnostic information, allowing maintenance personnel to quickly identify and resolve any issues with the fire pump system. The redundancy and reliability offered by having an individual ATS and fire controller for each fire pump are paramount. In a multi-pump system, if one fire pump or its associated controller malfunctions, the other fire pump can still operate independently, providing continued fire protection. This redundancy ensures that the building remains protected even if one component fails. Imagine a situation where one fire pump's ATS fails to transfer to the standby generator during a power outage. If each pump had a dedicated ATS, the other pump would still receive power for its working ATS, ensuring that at least one pump remains operational. Similarly, If one fire controller malfunctions, the other fire pump can still be activated and controlled by its functional controller. This level of redundancy is critical for maintaining a high level of fire protection reliability. Compliance with codes and standards is another crucial reason for having dedicated ATS and fire controllers for each fire pump. NFPA 20.1 standard for the installation of stationary pumps for fire protection, and NFPA 110.1 standard for emergency and standby power systems outline specific requirements for fire pump installations, including the need for dedicated ATS, fire controllers, and power sources. These standards are designed to ensure that fire pump systems are installed and maintained in a manner that provides reliable and effective fire protection. NFPA 20.1 specifies the requirements for the fire pump itself, including its construction, performance, and testing. It also addresses the installation of the pump, including the water supply, discharge piping, and electrical connections. NFPA 110.1, on the other hand, focuses on the emergency and standby power systems that supply power to the fire pump. It outlines the requirements for the standby generator, the ATS, and the electrical distribution system. These codes and standards are constantly evolving to reflect the latest technological advancements and best practices in fire protection. It is essential to stay up to date with the current editions of these standards to ensure that your fire pump system is compliant and provides the highest level of protection. In addition to NFPA 20.1 and NFPA 110.1, other applicable codes and standards may include the National Electrical Code, or NEC, and local building codes. The NEC provides detailed requirements for electrical installations, including the wiring, grounding, and overcurrent protection of fire pump systems. Local building codes may also have specific requirements for fire pump installations, such as the need for fire-rated enclosures or special seismic bracing. Ensuring compliance with all applicable codes and standards requires a thorough understanding of these requirements and careful attention to detail during the design, installation, and maintenance of the fire pump system. Failure to comply with these standards can result in fines, penalties, and, more importantly, a compromised fire protection system. In summary, each fire pump should have its own dedicated ATS and fire controller to ensure a reliable and independent power source and control mechanism in the event of an emergency. The ATS provides automatic transfer to the standby generator during power outages, while the fire controller monitors and controls the pump's operation and protects it from potential failures. Redundancy and reliability are enhanced by having dedicated components for each pump, and compliance with codes and standards is essential for ensuring a safe and effective fire protection system. By following these guidelines, you can ensure that your fire pump system is ready to respond effectively in the event of a fire, protecting lives and property. Now let's consider some practical aspects of implementing these requirements. When selecting an ATS for a fire pump, it is crucial to choose a model that is specifically designed for fire pump application. These ATS units are typically more robust and reliable than standard ATS units and are designed to withstand the demanding requirements of fire pump operation. They often feature heavy-duty contacts, faster transfer speeds, and more sophisticated control logic. The ATS should also be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or to ensure that it meets applicable safety standards. The fire controller should also be selected with care. It should be compatible with the fire pump and the fire alarm system and should provide all the necessary monitoring and control functions. The fire controller should also be easy to program and operate, and it should provide clear and concise diagnostic information. Like the ATS, the fire controller should be listed and labeled by a recognized testing laboratory. Installation of the ATS and fire controller should be performed by qualified and experienced personnel who are familiar with fire pump systems. The installation should be done in accordance with the manufacturer's instructions and all applicable codes and standards. Proper wiring and grounding are essential for ensuring the safe and reliable operation of the system. Regular maintenance and testing of the ATS and fire controller are also critical. The ATS should be inspected and tested periodically to ensure that it is functioning correctly. This includes verifying the transfer speed, checking the contacts for wear and tear, and testing the control logic. The fire controller should also be tested regularly to ensure that it is monitoring the pump's operating parameters correctly and that it is responding appropriately to alarm signals. These tests should be documented, and any issues should be addressed promptly. In addition to regular maintenance and testing, it is also essential to have a well-defined emergency response plan in place. This plan should outline the steps to be taken in the event of a fire, including who is responsible for activating the fire pump, how to verify that the pump is operating correctly, and how to address any potential problems. The emergency response plan should be regularly reviewed and updated, and all personnel who are involved in fire protection should be trained on the plan. Now, let us consider some additional points related to the power supply to the fire pump. The power supply to the fire pump must be reliable and capable of providing sufficient power to operate the pump at its rated capacity. The normal power supply is typically provided by the utility company, while the emergency power supply is provided by a standby generator. The standby generator should be sized to meet the power requirements of the fire pump, as well as any other essential loads that need to be powered during a power outage. The generator should also be equipped with an automatic startup system that initiates the generator upon sensing a utility power failure. The transfer switch should be located as close as possible to the fire pump controller to minimize voltage drop and ensure reliable operation. The wiring between the transfer switch and the fire pump controller should be sized appropriately to carry the full load current of the fire pump. Overcurrent protection should be provided for the fire pump circuit to protect against short circuits and overloads. The overcurrent protection device should be sized in accordance with the National Electrical Code, or NEC, and should be selected to coordinate with the fire pump motor's starting characteristics. Grounding is another critical aspect of the electrical installation. The fire pump, the transfer switch, and the generator should all be properly grounded to provide a low impedance path for fault currents. The grounding system should comply with the requirements of the NEC. In addition to the electrical requirements, there are also some mechanical considerations to keep in mind. The fire pump should be installed in a location that is protected from flooding, freezing, and other environmental hazards. The pump should be securely mounted to a solid foundation to prevent vibration and noise. The piping system should be designed to minimize friction loss and ensure adequate water flow to the fire pump. The fire pump should be equipped with a pressure relief valve to prevent overpressure in the system. Regular inspection and maintenance of the fire pump and its associated equipment are essential for ensuring reliable operation. The pump should be inspected regularly for leaks, corrosion, and other signs of damage. The motor should be lubricated according to the manufacturer's recommendations. The packing gland should be adjusted to prevent excessive leakage. The fire pump should be tested periodically to verify that it is operating correctly. This test should include measuring the pump's flow rate and pressure, as well as checking the motor's voltage and current. The test results should be documented, and any issues should be addressed promptly. By paying attention to these practical aspects, you can ensure that your fire pump system is installed and maintained in a manner that provides reliable and effective fire protection. Finally, let's touch upon some advanced concepts related to fire pump systems. One such concept is the use of variable frequency drives, or VFDs, to control the speed of the fire pump motor. VFD can provide several benefits, including reduced energy consumption, improved pump performance, and reduced wear and tear on the pump and motor. VFD allow the fire pump to operate at the optimal speed for the given fire demand, rather than running at full speed all the time. This can significantly reduce energy consumption, especially in systems where the fire demand is often less than the pump's rated capacity. VFD can also improve pump performance by providing smoother starting and stopping, reducing pressure surges, and improving system stability. In addition, VFD can reduce wear and tear on the pump and motor by reducing the stress in the mechanical components. Another advanced concept is the use of remote monitoring and control systems for fire pump systems. These systems allow operators to monitor the pump's operating parameters remotely, such as pressure, flow rate, motor temperature, and water levels. They can also provide remote control capabilities, allowing operators to start and stop the pump remotely, adjust the pump speed, and reset alarms. Remote monitoring and control systems can provide several benefits, including improved system reliability, reduced maintenance costs, and faster response times to emergencies. They can also provide valuable data for analyzing system performance and identifying potential problems. The implementation of these advanced concepts requires careful planning and design. VFD should be selected to match the fire pump motor's characteristics and the system's operating requirements. Remote monitoring and control systems should be integrated with the fire alarm system and other building automation systems. Proper training is essential for operators to effectively use and maintain these advanced systems. Another aspect to consider is cybersecurity. As fire pump systems become more connected and integrated with other systems, they become more vulnerable to cyber attacks. It is crucial to implement appropriate cybersecurity measures to protect the fire pump system from unauthorized access and control. These measures should include firewalls, intrusion detection systems, and strong passwords. Regular security audits and vulnerability assessments should also be performed. The use of redundant systems is another important consideration for ensuring the reliability of fire pump systems. Redundant pumps, controllers, and power supplies can provide backup in the event of a failure. These redundant systems should be automatically switched over in the event of a failure to minimize downtime. Regular testing of the redundant systems is essential to ensure that they are functioning correctly. In addition to these advanced concepts, there are also several emerging technologies that are being developed for fire pump systems. These include advanced sensors, predictive maintenance algorithms, and artificial intelligence-based control systems. These technologies have the potential to further improve the reliability, efficiency, and performance of fire pump systems. In conclusion, each fire pump should have its own dedicated ATS and fire controller to ensure a reliable and independent power source and control mechanism in the event of an emergency. By understanding the reasons behind these requirements, following best practices for installation and maintenance, and considering advanced concepts and emerging technologies, you can ensure that your fire pump system provides the highest level of protection for your building and its occupants. And always remember to consult with qualified professionals and adhere to all applicable codes and standards to ensure the safety and effectiveness of your fire protection system.